about inequalities. And a way that I like to relate it to is equations. So inequalities are very similar to equations, but we can't get that confused with equations exactly because we're talking about something being greater than, less than, greater than or equal to, less than or equal to. So these are all important points that we have to recall. So when we're doing this, we're going to have to graph this on a number line, and we're going to have to be able to know in which direction we're going and be able to properly read the graph that we're using. So let's take a look at this problem and see how we would solve it. So we are going to do combining our like terms on this side, so 7n minus 7n. That gives me 0. I have to write that 0 as a placeholder. So I put 0 is greater than or equal to negative 14n plus 14 minus 18 plus 12n. Then I combine my like terms like I would for a normal equation. So when I combine them, I get negative 14n and 12n together, which give me negative 2n. I combine these two, my constants, and I get negative 4. Because our coefficient to our variable is negative, I am going to want to move that number over. When we solve an equation, we need to get the variable alone and the constant on its own side. So we're going to do the same thing in this inequality. So I'm going to move over the two ends. We do not have to flip the sign. We were going to divide later. We're going to use division now. And I get n is greater than or equal to negative 2. Now I'm going to plot that on my number line. So my number line, I have negative 2 here. Because we have the or equal to sign, we are going to use a closed circle. And then because it says greater than, we're going to do all the numbers that are greater than negative 2. If we went to the left, those numbers are less than negative 2. That's not going to help me. We want to see on our number line, 1 is greater than negative 2, so we know we have to go in that direction. So that's the way I like to think about it, figuring out which way we're going to go by looking at our number line. Let's try another problem. Now for this problem, we have variables on both sides. We have another distribution. Let's see what we have to do for this. So I'm going to rewrite that left-hand side, and then I distribute. Because both coefficients of the variables are the same, it does not matter which one I move over first. So I'm going to move over this one, and I get negative 36 is greater than negative 28. Is negative 36 greater than negative 28? No, it's not. So because that does not make sense, the answer is going to be no solution. If it did make sense, it would be infinite solutions. But because negative 36 is more towards our left side on our number line than negative 28 would be, it's no solution. So this is one of our special cases where our variables cancel out and we're left with an inequality that is not making sense. Let's see another problem and determine if it's going to be a no solution, infinite solution on one of our regular problems. So again, we have a distribution problem. So I distribute, I get negative 9 minus 9m minus 6m is less than negative 129. Combine our like terms, which are these two. Add our 9 over like we would for our regular equations. So now we're here. We have negative 15m is less than negative 120. And I'm going to divide by negative 15. And I get m. When we divide by a negative, we must flip the sign. So it becomes greater than 8. If we forget to flip that sign, we're going to get the wrong answer, but also our number line is going to be wrong. So we have 8. I'm going to put an open circle on it. And because it's greater than, I go to the right. If I didn't flip the sign, I'd be going to the left, which is a total different set of numbers. So that's going to mess everything up. So these are how you do our regular inequalities. We're going to step it up a notch and we're going to look at some compound inequalities and see how we change our mindset based off of that. So this is an example of one of our compound inequalities, and it might look a little scary to us. However, if we break these up, we are going to be able to see that all we are doing is solving our first inequality and our second inequality and putting them both on the same number line. So it might seem a little bit scary, it's just going to be a little bit more work. And I like to say a little bit more work, but that's a little bit more fun, isn't it? So I am going to solve my first inequality. Once again, we have the variables on both sides. I'm going to move over the negative 10a because that coefficient is smaller. If we chose to do the other one, that's okay. We'd just be dividing by a negative, which means we have to flip the sign. This becomes plus 3a. Subtract our 5 because we want to get our variable alone. Then I divide by negative 3. When I divide by negative 3, not negative 3, positive 3. We're dividing negative 3 by positive 3, and we get negative 1 is less than a. That might sound confusing though. Negative 1 is less than a. You heard me speaking throughout this whole entire time saying 2 is less than 5a plus 3a. Negative 3 is less than 3a. I like to say this either out loud when I'm by myself, or I like to say this in my head so I'm remembering which way I'm going when I'm graphing this. So if I read negative 1 is less than a, that might be a little bit confusing.
But if we read from right to left,
we get a is greater than negative 1. So I'm going to put an open circle here on negative 1, but I'm going to put a faint line on here. Just to remind me that I'm going in that direction. I might have to erase it based off the next problem, but for now we're going to do this. Most of the time, if we don't have a special case, we're going for an or compound inequality. One go one way, one go the other way. But I just do this just in case it's one of our special cases and we can't just go in one direction versus the other. So let's look at the next one. We have 9a plus 5 is greater than 9a plus 2. Because they're both the same, we can subtract either, so I chose this one. I get 5 is greater than 2. Is 5 greater than 2? Yes, so we have infinite solutions. So now this is where it becomes a little bit confusing. So we're like, wait, we have an answer, we have an infinite solutions, which is an answer, but that's every single number. So what does this mean? Well, this is because it's an or situation. This is saying that our answer is either a is greater than negative 1 or infinite solutions. That both of these answers suffice this problem because we are asking for the answers to either this one or this one. Usually when we have a compound inequality problem, we're not choosing which one makes the most sense. We're not even trying to realize why one would make sense over the other. Both the answers usually are the ones that make sense. But when we run into a problem and we get infinite solutions or no solutions, we need to look back at what type of problem we're working with, which is a or compound inequality. And because one of them is infinite solutions, the whole answer is infinite solutions. And some books or some softwares like to say that the answer is all real numbers. Those are the same thing. So to graph that, we are going to just put every single number on the number line as our answer. So we have to be careful though. If one of our solutions is infinite solutions for an or problem, that's when it's infinite solutions. You can't always do this for and one, so we're going to have to be careful with that one. Now let's take a look at another problem that's a little bit more basic. It's not as intense of trying to decipher which answers make sense and not. Now we have this problem. It's another or statement, so it should be going in opposite directions when we graph it on a number line. We also are asked to put it into full notation. So there's a lot of stuff going on in this problem, which means we get to have ample time to show all our knowledge. So we're going to start off by solving this one on the left. 8n is smaller, so I move it over. Now we move that 3 over. We are going to divide by that 2. The 2 is the coefficient, so I divide it over, and I get negative 5. So I see n is less than or equal to negative 5. So I'm going to graph that. That would be in between here. I put it in a closed circle, and I'm going to be going in this direction. Like I said, I put that little faint line that I can erase later. Now let's try this problem. Negative 3n's is smaller, so in my method, that's what I would move over. Add that 7 over. And divide by my 2. And we get n is greater than 8. So I'm going to put an open circle on 8, and I go in this direction. And now we can fill it in because we are going in opposite directions like we wanted. So we probably have done this right. Obviously, we could have a number off, and if I divided this by 2 and said it was 7, we're off, but at least it coincides with our or statement, and it's not one of our special problems where we have infinite or no solution. So other than having an or compound inequality, we have another compound inequality called the and one. So we're going to look at the and compound inequalities and see how we complete that type of problem. If we have our number line looking like this, we have to put this in interval notation. What really matters is the number line. If we take a look, our numbers are coming this way. So we start with our smaller number, which is going to negative infinity, because these are our negative numbers. It's going to -5, and because it's a closed circle, we use a bracket. We're missing everything on the inside here, so we have to use the union to union these two together. We glue them together. Now, this starts with 8, so we have a closed parenthesis, and we're going to infinity. So when we have an or statement, this is when our interval notation gets a little crazy, where we need to have that U for the union. We have our bracket for our closed circle and our parenthesis for our open circle. We always use parentheses when we're working with negative infinity and positive infinity, so be careful of that. Now let's look at a problem where we have an and compound inequality. So there are some different steps we take. It might look a little bit more complicated, but I'll show you how we do it. So for an and inequality, compound inequality, you might see it as this inequality and this inequality, or they might sandwich it together like they have now. So we are going to want to, in a sense, break it up, but this middle portion goes with both of them. So we are going to use that in both inequalities. So I'll have -5x minus 8 is less than or equal to 7 minus 8x, and let's solve that. The x is smaller, 3x minus 8 and 7. Then we add 8 to both sides. And we get 3x is less than or equal to 15. Divide by 3. We get x is less than or equal to 5. So I'm going to put that on my number line. Close circle to this direction, just to remember which way I'm going. Because this is an and, they're going to be going towards each other. I don't know how far. Maybe I'm going all the way down here. Maybe I'm stopping here. So I put that light shading to remind myself that that's the way I'm going. So when I finish it, I can continue. Now we're using this again. I add 8x over, and I get 7 is less than 7 14x. So I get 7 is less than 7 plus 14x. I subtract 7 from both sides. I get 0 is less than 14x. Divide by 14. And I get 0 is less than x. Usually, some of my students see we have the 7's going to the other side. We're left with 0. That's infinite or no solutions. No, we have to be able to divide by the 14 because our variable is still here. Our variable was going to be one of our special cases. Because the variable is still here, we have this answer. So we have, if we read left to right, our little alligator is going this way, so it's saying that x is greater than 0. So I do an open circle, and we're going to be going this way so I can shade in between. And because we had an and statement, that's what we wanted. We wanted them to be shaded in between. And then we're going to put an interval notation. So our numbers are going from 0, which is a parenthesis, it's an open circle, comma, it's going all the way to 5, bracket. So this is saying 0 to 5. This is not saying the 0.05, this is interval notation saying the answers range from 0 to -5, not including 0, including 5. So I hope these type of problems are helpful for you to determine how you complete inequalities, but also compound inequalities.